If you're watching this video, there's a pretty good chance you already watched my videos on capital budgeting and the time value of money. Now, if you did look at those capital budgeting videos, you know that we used some time value of money tables, in particular, present value of a single sum and present value of an annuity, in order to come up with present value calculations. Now, that might be fine in the textbook world, but I'm here to tell you that accounting and finance professionals don't pull out their college textbook and look at those tables to perform present value calculations. They're a good way to dip your toe in the water, but I wanted to show you how to do this in Microsoft Excel. Now, Excel is extremely powerful, tons of functions. And I'm just going to go over two of them, NPV and XMPV. Now, that being said, there are plenty of present value functions. And before we get too deep into those particular two functions, I just want to give you some general guidance, because I know that people watching this video have varying degrees of basically familiarity with Microsoft Excel. Some people use it all the time and are gurus, and other people, maybe not so much. So if you're ever looking for a function and you're not sure what you might need, well, you can go here. There's a formulas tab. See where my mouse is kind of hovering there? You can go to insert function here and search. Okay, so let me just type in present value. Well, look at that. Lots of different functions coming up, including NPV that we're going to look at, XMPV that we're also going to take a moment and look at, but there are also present value, future value, internal rate of return should show up here. So if you're looking for a function but you don't know what you're looking for, sometimes this can be a great starting point. And if you happen to select that function, well, click on it, and Microsoft Excel will do a really nice job of walking you through the inputs that you need to identify. And if you need even further help, I mean, just like a lot of software, you can click help on this function and it'll give you information about the syntax and even the underlying formula so that you can kind of break that apart if you needed. Lots and lots of detail. But in this case, I'm just going to go through and show you these two functions. So in the capital budgeting analysis, we looked at a company that had a chance to get a new contract with a customer, but they had to spend some money in order to make some money. They had to spend $160,000 to buy some equipment. They had to tie up $100,000 in terms of working capital. 3 years down the road, they were going to have to spend $30,000 to slightly overhaul the equipment, reline it. 5 years at the end of the project, they expected to sell the old equipment for $5,000 and then release that working capital that was tied up early in the project. And oh, by the way, this is the attractive part of it. They expect to get operating cash inflows of $80,000 per year. Wonderful. Well, we did this calculation, the $76,000, and we said, okay, great. The present value is positive. It's largely positive. And so that means that the rate of return for the investment is more than the 11% discount rate we're using. And we said, okay, let's go ahead and do the project. Now what I want to show you is this. I've got some cells hidden. If you want to use the NPV function, you can do it. But you have to aggregate your cash flows by year or by time flow. Okay? So in other words, take a look at what's happening right now, which I called year zero. Let me just put a highlight on that. In year zero, the initial year, you're going to spend $260,000. Now, when we did the analysis for capital budgeting, we had those as two separate rows. If you want NPV to work properly, you've got to combine those cash flows into a single amount. And then what happens is years 1 and 2, we get the $80,000 per year coming in the door, which is great. Okay, here there's the $80,000. But now in year 3, we need to net the $80,000 inflow for that year with the $30,000 going out the door for the relining equipment. So in year 3, as you can see here, the net cash inflow is only $50,000. In year 4, we just have the $80,000 right there. But then in year 5, where everything kind of gets settled up, we have, let me just show you what's part of this. We have $80,000 coming in. We've got another $5,000 coming in because we sell the old equipment, and then we have $100,000 for the release of the working capital. Add these amounts, that's the $185,000. So using the NPV function, we have to aggregate the net cash flows by period. In this case, our periods are years. It could be months or weeks or whatever, quarters. So we start with the formula, equals NPV. Okay. First thing it's asking us for is a rate. Now I'm going to hard code the rate as 0.11, 11%. In a lot of capital budgeting models or other financial analysis models, that rate will probably be a variable somewhere else in the Excel workbook so that the workbook analysis can be dynamic and you could make different analyses at different rates. You know, you can kind of slice and dice. Now I know that the formula looks like it's saying, okay, give me value 1, 2, 3, 4, etc. All right. Well, let's go here. We can comma, 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 comma. Great. And you're looking at this and you're saying, I thought the net present value was supposed to be something like 76 grand. Well, it is. We did not include this first initial cash outlay. So we need to add that into the mix right here. There is no time value of money factor for that. And you can see we're pretty darn close. Okay, we're within, you know, what is that, $33? Yeah, $33 from our previous analysis, which really for managerial accounting decisions, that's close enough. But I want to explain why that's the case. The biggest thing here is that the analysis we did down here where my mouse is hovering used rounded factors, okay? So we just rounded these factors to 3 digits. They really go on for infinite number of digits. So that's the biggest factor that's influencing the slight difference in the net present value between the Excel function and the present value we calculated by hand over here. Now I want to redo the calculation one more time, just to show you that you don't need to put those individual cash flows in terms of those commas. So let's start here. Cash flow in year 1, $260 going out the door. Now let's add that to the net present value at 11% of these cash flows right here. So we didn't really need to do comma, 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 comma for each of those years. If we go back and look at this formula that's right here, look what's happening. We're basically saying the net present value, here's the rate, and oh, by the way, the values, the actual cash flow values, D4 through D8 with a colon. That's a range of values. There are a lot of times where Microsoft Excel will allow you to put a range in, and then you can more efficiently get to the data. So that's one way of doing it. But you can see that we had to do a little bit of work combining the annual cash flows to get things to work out. And just for giggles, I will tell you, if you add up these cash flows, it's $215,000. That is the total of these dollars down here as well, assuming that you understand that this line here is really $400,000 because it's $80,000 a year for 5 years. What if you didn't want to go through that hassle? We could go with XMPV. Now, I've got the same depiction here of our previous analysis, but let me unhide some of my rows. Now, what I've done here is I did not need to net the cash flows by year. I was able to have these individual cash flows. Here's the purchase, here's the salvage value. Look at year 3. We didn't have to net these as 50,000. By the way, this is a kind of a cool Excel function. Look down here where my mouse is hovering. Whenever you highlight something in Excel, the program will automatically give you the average, the count, and the total. It's a pretty quick way to do math. The total of these is 215. There are 10 of them. The average is 21,500. So as you can see right here, we didn't need to, in year 3, we did not need to net these as $50,000. We were able to have the individual cash flows. Okay. Now, so what we do with XMPV is you basically start with the formula, XMPV. The discount rate gets hard entered just like before, but now it's definitely looking for ranges of values and ranges of dates. Comma values, comma dates. So the range of values is right here. Put a comma. The range of dates is right here. And very quickly we have our present value. And I already know what you might be thinking. Really? That doesn't equal anything. I mean, we come up with a present value, 75,973. The manual method was 76,015. And if we go over to the NPV, it was 76,048. Will the true net present value please stand up? Well, here's the reason for the difference between NPV and XMPV. There's a leap year in here, guys. And I forget exactly which one it is. You can go to Google and figure it out. By the way, Google can sometimes even help you figure out how to use Excel formulas. I'm not ashamed to say that I've used it as a resource from time to time. Okay? But somewhere in here, I think it's 2020 or 2021, there's a leap year. So that little difference between NPV and XMPV is explained by the fact that there's an extra day in there. Okay? Either way, I think you'll agree that whether the net present value is 75,973 or 76,048, we have a $76,000 net present value, and that's certainly enough to tell us that this is an acceptable project. Now, one of the things I like about XMPV is that a limitation of NPV, or net present value, is that we assume the cash flows happen at the end of the period for simplicity. XMPV, you don't have to have that assumption. I mean, there's a pretty good chance that we did not purchase this equipment and invest the working capital on New Year's Eve. There's a pretty good chance we weren't even working on New Year's Eve. Most people take the day off. So what if it turns out, and I just want to keep in mind, let's do this. Let's take a little snippet of what our present value looked like. If you've never used the snipping tool, by the way, in Microsoft Excel, very useful. Okay, we'll just copy that over here. Should be able to just paste that. So this is what our initial NPV analysis looked like. I'm just putting that over there as a reminder, okay? So we can see what that net present value was. Now let's say we paid for the equipment on December 1 of 2018. Look what happens to the net present value. Changes by a little bit, right? And well, we could go even further. Let's say that we bought that equipment middle of the year. Now the net present value really starts to change. Okay, so one of the things I like about the XMPV is that this function is basically looking at the dates of these cash flows in relation to the magnitude of the cash flows. And if the dates change, the present value calculation changes. Okay, so it's a dynamic tool. These are just two possible ways of using Microsoft Excel functions to do present value. And Microsoft Excel is not the only software tool. I have an app on my phone that will do it, and there are plenty of other wonderful pieces of software that will help you perform this analysis. I wanted you to just have this little bit of illustration.